Today is Dr. Sandeep Sibal. He is BTech Electrical 88 batch. Before he starts his talk, I've asked him to confess to what he used to get up to when he was a student here. So we'll spend a few minutes talking about what he used to do when he was a student. He is now country manager and VP of business development for Qualcomm India and South Asia. And he's going to be talking about the smartphone revolution. I'm glad to see a good turnout today, given that you have quizzes going on, and hopefully, and I'm sure that your expectations will be fully met by Dr. Sibal.
So, welcome everybody, and I think for this hot afternoon, it's a fine turnout. I remember sitting where you're sitting 25 years ago. And for some reason, when I walked in today, it just seemed a little smaller than it used to be. I'm not sure why, but it's a real pleasure being here, and an honor as well, coming back to the school where you studied to give a talk. So I graduated in 1988 with a bachelor's, like Professor Nagarajan said, in electronics and communications engineering. So I graduated in 88 with a bachelor's in electronics and communications engineering, and I just visited ESB to look at my old department, and it actually hasn't changed as much as I thought it might have. I also went to my old hostel, Jamuna, and Jamuna has changed a little bit. I think the entrance is pretty much the same, but back then we used to have the mess on the right side. I think the mess has moved out. We had, I think, 2 floors above the ground. I think now there are 3, and a couple of other changes. But for the most part, it really brought back a flood of memories. I also visited the loo because a lot of funny and interesting incidents that happened there. Unfortunately, I can't share all of these here in front of this August gathering, but lots of pleasant memories. I was just talking to Professor earlier that things have changed so much in other ways outside of this campus. Obviously, major changes in the world of politics, the way the world works, a far more connected world, a lot more changes also socially and culturally as well. And perhaps, sitting inside IIT Madras, we were pretty much oblivious to a lot of those kinds of developments. On my flight here this morning, I was reading the papers, and there was a story on Rajiv Khemka, the gentleman from the, I think he's from the Haryana IS cadre, who's been transferred, I think, 44 times in 20 years, also an IIT graduate. And it struck me that a lot of the graduates of IIT, who passed out a couple of decades ago, have certainly made their mark in the space of technology. But there are many others who have also contributed in other ways. One of my batchmates, Kannan, who's actually here with me, he's done some tremendous work, innovative work on addressing solutions for rural India. I'm not sure if he's given a talk before, but if he hasn't, you should invite him for a talk. He has given a talk, great. There's another classmate of mine, Anant Padmanabhan. He went on to I think lead Greenpeace India and Greenpeace International, and now he's the head of Amnesty International, doing some very good work, again outside of technology. So we're seeing IITians contribute in so many interesting ways beyond technology. Of course, within the space of technology, we've had some incredible alumni of IIT Madras and many of the other IITs as well. Deshpande is somebody who came up in conversation over lunch today while we were having chit-chatting with your director, Professor Bhaskar Ramurthy. So a lot of contributions, and looking back at the 25 years, you know, I've been trying to search for where does the inspiration for a lot of these developments in your later life come from? Do they come from the place where you, you know, where you studied or not? And I don't think I have a good answer to that question. But suffice it to say that it was really tremendous connecting with the Institute once again after all these years. One of the things that struck me was that back then Chennai was almost as hot as it is now. Yeah, sure, global warming may have added a fraction of a degree, but it was still very, very hot. And we used to run to either the library, I'm not sure if it's still the way it was, or some of the research labs or the computer room to actually get into an AC setting, because there was no other place on campus that had any air conditioning. So that was a big, big draw for us. And I remember occasionally people going to the library, you know, putting their heads down, opening their books and going to sleep. And the guy would come around saying, look, if you're sleeping, you can't be here. He said, no, 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 I'm actually reading the book, because, you know, all he wanted to do was basically be inside the air-conditioned room. So some interesting anecdotes of that kind. We did go to the OIT. I think the OIT still looks just as nice as it used to previously, and of course many of these other landmarks at IIT. Anyway, in the time that I have, I want to actually focus your attention to something that has really changed our lives, and that is the smartphone. And the reason I chose to speak on the smartphone today was because the smartphone not only is key to many of the changes that we have seen take place over the last few decades, both abroad and in India, but in my opinion and in the opinion of the company I work for, Qualcomm, we believe that revolution has just begun. So I wanted to draw your attention. Some of this is actually very topical, especially if you're pursuing a degree in electronics or computer science, or even many of the other adjacent areas. You would probably find this talk interesting. My intent is to, I think I have something like 10, 12 slides, not a lot of slides. So I'll go along. If there are any clarifications that you want in the middle of my talk, feel free to interrupt me. Otherwise, at the end of the talk, we'll have a lot of time for Q&A. So once again, I hope you find this useful. And let me start off. If you just stop, please. So I guess you can see this. It's a little dark, but you should be able to see it. The picture really is that of a woman on a Bombay local playing with a smartphone. And I don't know if many of y'all can recognize the gentleman on the top left. Can anyone recognize who he is? I guess not. So he's, I'm sorry? That's right, okay. Excellent. I don't know if you're giving out free smartphones, but if we are, that's bang on. His name is Martin Cooper. And this is actually him holding the first cell phone. You know, that cell phone actually weighed more than a kilo. And when it was sold in the market, I think it was sold for $4,000. And of course, you know, all it could do, and that too barely, was to make a voice call, right? And in fact, the smartphone that this lady is holding in her hand, sitting in the Mumbai local, is, you know, far more powerful than any of the computers we used to work with when I was at IIT. In fact, in my first year at IIT in '84, there were no computers. The only one was an IBM 370. I don't think you'll know what that is. It was this huge, you know, I actually never saw it. It was behind the wall. And we actually had to write our program in Fortran. It would get compiled, and, you know, sort of, we had these punch cards. We take a stack of them, then you had to submit it. It would be fed to the machine, and the machine would simply give an output, a printout. I think the first time I wrote a program was to solve the 8 queens problem. I don't know if you all know what that is. Essentially, how do you place 8 queens on a chessboard so that you know, none of the queens threaten any other. So actually, that was what a computer meant in '84. And things didn't change much else even when I graduated in '88. Back then, and I'm now jumping out from the flow of the talk, but I'll get back to it. Back then, the big challenge in semiconductors was how do you get to sub-micron technologies, right? Because the geometries back then were in microns. Today, I think the chips that Qualcomm makes, we make it at a geometry, a node size of 28 nanometers, which is what 1/30th that of what was the size of the geometry of chips back in, back when I graduated. So things have changed a lot. But the point I was trying to make here was that, this is in fact what has happened over the course of the last 30, 40 years. And this has, of course, changed things in many, many ways. The talk that I have today is more technically oriented. I've not chosen to focus on the potential of this smartphone revolution, in the space of culture, society, politics. But we can talk on that as well, maybe over the Q&A. So, so this is a very simple slide. As you can see, there are just 3 numbers out there. And remember, the population of Mother Earth is around 7 billion, a little shy of 7 billion or a little bit more than that. And today we have 6.3 billion wireless connections worldwide. Now, this doesn't necessarily mean that 6.3 billion people are connected, but I believe that number is also pretty close to about 6 billion, 5.8, 5.7, something around that. So essentially, a good 2/3 to 3/4 of the world's population has a mobile phone, right? And that is tremendous when you think about it. It is, unquestionably the biggest platform in the history of mankind. I got back from the US 10 years ago, and to give you an idea, in India back then we had 10 million people with mobile phones. This was the end of 2002, and today we have 750 million. So that you can see that growth in India, and we have, of course, seen this globally. What's also interesting is that, many of those connections initially were for voice, right? That was, in fact, the first application for a cell phone. And Mr. Martin Cooper, who you identified correctly, was actually holding that phone, and all he was doing was actually making a phone call. But there's also now this whole question about what can you do on the data side, right? The move from feature phones to smartphones, accessing the internet on the go, and that's where 3G comes in. And I'll talk about 4G as well in a little while. And today there are about 1.8 billion people, or around as many, with 3G connections. And we believe by 2016 that'll go to about 3.4 billion. So not only are we seeing people having mobile phones using it for voice, often just on 2G, but we're now seeing people connect on 3G and in the future on 4G to actually access the internet and access all kinds of interesting data services on their smartphones. So I think this is a very important point. If you look at the growth, and this is the map of the world, you'll notice that much of the north, sort of Northern America, Western Europe, and so on, the growth there has already happened for the most part, meaning most of these folks already have 3G and 4G devices, they have 3G and 4G connections, and that growth has pretty much, sort of happened over the last decade. But countries like Latin America, like Middle East, Africa, India, and China is where the growth is happening today. And I'll focus on India in a little bit as well. But this graph is simply there to tell you that in a 5-year span, we see a huge expansion in terms of the total number of 3G and 4G connections. When you look at these numbers, just to give you a feel for why these numbers look different for different countries, a lot of it actually has to do with the income levels in different countries. So for example, the GDP per capita, which is kind of a proxy for income, in India is about $1,400 per year. In China, it's close to about 4,000. So essentially, people who have higher incomes tend to pick up 3G and 4G connections and smartphones as well, a lot earlier than in countries which have lower incomes. Now, this next chart makes up for the previous charts. It's got a lot of information on it, and I'll actually spend a few minutes trying to explain what has actually happened in India over the last 10, 12 years. So I don't know if you can see this from the back. No, you can't? Okay, can you at least see a red line, a curve? Okay, all right, that's probably plenty for now. So what I've drawn over here is, in fact, on the x-axis, the years from 2001 all the way up to 2016, right? And the red curve that you see is the total number of mobile voice subscribers in India, right? On the y-axis, thank you, right? Okay, it's not exactly. Anyway, this is the x-axis, and on the y-axis, right? This is 100 million, 200, 300, 400, 500, 600, 700, 800, 900, 1 billion. These are the number of subscribers. So as you can see, with respect to mobile phones, with respect to mobile voice subscribers, we saw a lift off towards the end of 2002, and it's been climbing, and it's kind of flattening out here. And this dip is a little bit of a interesting artifact, which I can explain as well if you'd like. But what I'm trying to say is that we've quickly climbed in India, right, from a country that had almost no mobile phones 10 years ago to a country that is, heavily penetrated with mobile phones. And of course, you see that around, right? Everybody today has a mobile phone, or almost everybody. Now, what you can't see, I think, is some of the fixed. I'll ignore the fixed. But the green one, can you see the green line, this other line at the back? Yeah? Now, this line actually is a line that shows mobile 3G and 4G connections, okay? And as you can see, this is almost 10 years delayed, right, from voice, and you see that climbing as well. Now, we only have data till 2012, so this is really, from 2012 onwards, this is simply a projection. But we're just on this curve. We're somewhere around here right now. So we're going to go up. So what we are seeing is a lot of this initial buildup was on 2G, which is typically technology that's optimized for voice, and 3G, which came after that, which is on data, and of course 4G as well, which again focuses on data. I'll talk about that a little bit more in a little while. What's also interesting, which unfortunately you can't see, I actually also have plotted the fixed voice subscribers, and that line actually runs flat, pretty much along the bottom of this graph. The fixed voice subscribers back 10 years ago, there was something like 40 million phone lines, right? Remember the old lines? You pick up the phone, the POTS, the regular old telephones. It used to be 40 million, and oddly enough, 10 years later, it's gone down. It's something like 37 million, because people are deciding that they prefer having their mobile phone with themselves, their own personal device, so that the total number of fixed voice subscribers in India actually has come down from 40 million to about 37 million, right? And the other story, which is actually a little bit more serious, is that the fixed broadband subscribers, so this is access to the internet from your home, right? So many of you all may have heard of DSL, right? So-and-so has a DSL connection, right? Now that, because of the fact that the copper loops, which carried the voice telephony, did not really grow from 40 million, the total number of data connections that utilize the copper cable, using a technology called DSL, also hasn't grown. So that's also pretty much capped. So what we are seeing is that, unless the government or maybe a operator with very deep pockets decides to dig and roll out cables for fiber optics, for coax, we're not going to see a lot of fixed broadband in the coming years, right? So what we are seeing in India is just like for voice, where the total number of fixed phone subscribers kind of was flat and the wireless mobile subscribers shot up. We're beginning to see the same phenomenon for data also, right? So connections to the home through DSL, those kinds of connections aren't really growing that much. But connections using 3G and 4G, which we're going to see very soon in India in a big way, are actually expected to rise. Now, there have been some very interesting, timeline, sort of milestones along the way. I'm not going to go through them, but maybe if you're interested, we can discuss this later. But suffice it to say that some of these stimulants that actually shot up this curve and made it really ramp up, one was the fact that we had something called calling party pays. This was an important development, and let me explain what that is. And this is probably before many of you all were, adolescents. Back then what would happen is if you had a mobile phone, if I called you, not only would I have to pay, but you would have to pay as well, right? So what happened was in 2003, they actually changed the system so that only the caller would pay, but the callee, the person who was on whom the voice call terminated, that person would not have to pay. And that actually allowed mobile phones to really proliferate, because then that meant that you were not at risk if you were simply to take a phone call. That was one important development. Another was that there was actually a limit on foreign direct investment into mobile operators. So when I say mobile operator, I'm talking about companies like Airtel, Vodafone, Idea, Reliance Communications, Tata. You've heard of them, right? So these mobile phone companies were looking for a fresh infusion of cash. So the foreign direct investment limits were in fact relaxed and increased all the way up to 74%. And many of the operators actually benefited from it. I think some of the other interesting, from 2009 we saw something called EVDO launch, a form of 3G. In 2010 we had 3G and BW auctions, and then of course we had the first LTE network launch in 2012, and of course we're seeing the 3G continue. I'm not going to go through each and every part of this, but basically the point is that due to a combination of policy interventions, what's also not shown here is that the price of devices came down. Back in 2010, a simple plain old voice SMS phone used to cost more than $100, the cheapest one. Today it's closer to $10 or $15. So the price of devices have really come down since then. The tariffs, meaning the amount you have to pay for a call a minute or the amount you have to pay for a megabyte of data, also has significantly come down. So various other changes also helped along the way. But basically the point is that the value proposition of mobile voice, so that anybody could call you from anywhere and could call you no matter where you were at any time of the day, clearly the value proposition was very strong for voice, right? Now, what's happening now is that as we reach, as we cross 700 million and we get close to 800 million, what's happening also is that the total subscriber base of India is beginning to flatten out, right? And why is that? Well, if you look at India, if you look at 1.2 billion people, something like 350 million of us are actually destitutes, which means we actually don't have food to eat. So that part of the market is really not there, and I guess Kannan can talk more on this, but essentially there is a segment of India that is so poor that even a mobile phone is out of reach. Second, there are of course children and other segments of the population that may not be able to get a phone. So when you look at that, we're actually beginning to flatten out. Now, this little bit of a dip has to do, is there because of an interesting reason, and I will leave that for later because explaining that will take a little bit of time as to why the subscriber base actually has dropped a bit over the last couple of quarters. Let me move on to the other slide so that we have time. I think one of the important points, of course, is this last one here, and that is that because of the fact that access to the internet and broadband is primarily going to be through the wireless mechanism of 3G and 4G for the masses of Indians, unless something changes on the fixed broadband side, the smartphone therefore will be most likely the first computer for most Indians. Okay, and that's unusual. I think most of you all seated here, you probably had access to a computer when you were growing up, right? But that's just, still a segment of privileged India. If you look at the rest of India, based on our current understanding of the market, for much of India, they will actually first experience the internet on their smartphones. Now that is actually quite unusual, and that is leading to some interesting demographic effects on how computing might evolve in India, on how certain services may be offered to people and so on. But I'll leave that for later. But clearly the smartphone is going to be even more important in some ways in India than it is in many other countries, because there they have alternate ways of getting to the internet. Okay, so this is a little bit of again, a busy chart. But this shows a smartphone in the middle here. And of course, there are a couple of different smartphones shown. What is happening with smartphones is quite interesting. Smartphone really is becoming almost a center of innovation for both computing and communications. There are a lot more smartphones sold worldwide than there are PCs or laptops, by multiple factor actually. And what we are seeing is that with the CPU, I guess everybody knows what CPU means, right? Okay, I guess the smile says the answer is yes. GPU, everybody okay there as well? Okay, all right, let's proceed. DSP and multimedia, okay there, all right. Modems, connectivity, sensors, and displays. There's a lot of innovation happening along all of these different dimensions, right? And you see this, right? Your friends come up with a new smartphone, you actually can see there are some new features that the old smartphones didn't have. And the innovation in this space is actually going through a very, at a very high pace, largely because it's such a large market. So a lot of companies, a lot of businesses, including Qualcomm, is focused on pushing the frontiers of different aspects of the smartphone. So let me just spend a minute on each of these. The CPU is in fact the entity that is responsible for computing for the most part. And what we are seeing now is over the last 1 or 2 years, the power of the CPU has actually crossed what most laptops used to be able to afford even a few years ago. So typically gigahertz processors, in some cases dual core, in some cases quad core. We are actually putting a lot of effort within Qualcomm as well to make sure that these CPUs are designed very efficiently so that they only wake up and they only exercise that part of the circuits that are needed for that particular task, right? So I was just giving that analogy to someone else earlier today. Imagine a CPU like the engine of a car, right? So let's say instead of a quad-core processor, you have a engine with 4 pistons, a V4 engine, right? Now, typically what would happen in a car is that all 4 will fire as long as the car is operational. But what we do with smartphone CPUs is that we can actually say, no, I want to shut off 2 out of the 4, I don't need them. The third one I want to operate at 50%, effort levels, and the first one I'll operate at full power. So what we're doing right now is actually, there's a lot of focus on how to increase the efficiency of the CPUs so that you can actually run the CPU without draining the battery. One of the themes that I won't be able to cover today is the fact that while many of these dimensions we've seen, explosive developments and very, interesting innovations, the space of batteries actually has not changed as much, right? So while processors have become stronger and stronger and able to generate a lot more MIPS, battery power has not kept up. So that tends to be a very important factor that you need to keep in mind while designing CPU. Furthermore, in the case of Qualcomm, we actually combine the CPU and the modem. The modem is the entity that connects to the wireless world, be it 2G or 3G or 4G, right? And the modems and the CPU, in the case of Qualcomm, it's all on the same chip, integrated. Now, why do we integrate all of this on the same chip? The reason is that when you have them as 2 separate chips, there are inefficiencies in communicating between the chips. So what we've done here is actually integrated the CPU modem. In fact, so is the GPU. GPU stands for graphical processor unit, right? It's similar to the CPU. The DSP multimedia, this is where we do a lot of the the image, video, and audio processing. Connectivity, this is typically to do with things like Wi-Fi, Bluetooth, FM, and so on. The sensors, now this is an area that is also really expanded. So back in the early days, the only sensor you had was a microphone or maybe a camera. But today you have a accelerometer. You actually have GPS that can sense where you are. In fact, one of the things that we have in our more recent chips is that we've also combined not just GPS but GLONASS. GLONASS is the equivalent of GPS, but using Russian satellites. So you can even get even more precise location of where you are. So we've got proximity sensors, pressure sensors, sensors for light, ambient light, gyroscopes, temperature, magnetometer, humidity, and gestures, right? So you can even from distance swipe and interesting things can happen. So there's a lot of stuff happening on sensors and a lot of applications leveraging these sensors to do interesting things, right? And finally, of course, we have displays, and there's a lot of innovation now on displays, right? As you know, most of these are capacitive, touch interfaces on today's smartphones. But then again, there's a lot of work being done on how to render clearer images at multiple angles, displays that can render 3D and so on and so forth, flexible displays and so on. So there's a lot of work going on there as well. So a lot of each of these areas, we're seeing developments. We're not going to cover this today, but if you're interested, we can walk through, some of these after the main talk. Now, I'm going to shift gears a bit. So I guess what I've told you till now is that, mobile phones are the biggest platform, smartphones on the rise. Most of India will actually see computing and actually experience the internet through a smartphone. And of course, smartphones will, become more and more capable, integrate more sensors, do more interesting things. But you see, a lot of the issues that we are facing today in the Indian setting are not just to do with smartphones and the capabilities per se. A lot of it has to do with the fact that these smartphones are now beginning to consume more and more data, right? As you access interesting applications, it's got to download content. And the issue is that 3G and 4G, which is what I call broadband here, the spectrum available in India is not enough. So what I've drawn here actually is to give you an idea as to what's going on globally. And as you can see, do you all understand what spectrum means? Most of you all, many of you all do, okay. Some of you all are shaking your heads, but I don't think everybody is. But essentially, think of it as oxygen for the telecom industry, right? The more spectrum you have, the more phone calls you can make, the more data you can download, okay, or upload. So what we are seeing here is that this is India, and compared to many of the other countries, this is the amount of spectrum available in megahertz. Most of these, as you can see, are 200 and above. In India, we're only at about 100 megahertz. So one of the critical things that we need to do in India, and this is of course stuff that we're working with regulators on, is to open up more spectrum for mobile broadband, right? Because if you have only a little bit of spectrum, there's only so much you can do with it, right? Think of it like a highway. It's like broadening the highway, right? The broader the highway, the more cars can travel. So this is an area that we were trying to see how can you open up more spectrum. The more spectrum you have, the more data you can push. So this is an area, I'm not going to talk a lot about it, but you may have heard a ruling recently, if you're reading the papers, about the fact that Airtel, for Airtel users, there was a ruling which said that users will not be able to roam on 3G in circles or in states where Airtel does not have 3G spectrum. Have you all read this article recently? Okay, some of you all have, all right. So essentially, why is that? What happened was when we had 3G auctions back in 2010, there were 5 or 6 dominant nationwide operators, right? They all wanted 3G. But the number of slots that were auctioned were only 3. So you had 6 operators and 3 slots, right? So none of the operators got nationwide coverage, right? So India is broken up into 22 circles, roughly one per state. So what we actually had was a case where every operator had some circles, the big 6, but none of them had all India. And so what they were doing, they were leveraging each other's spectrum when their subscriber would roam into a circle where they didn't have the spectrum, right? Make a long story short, my point is that a lot of the issues that operators are facing is because there isn't enough spectrum that has been auctioned for 3G yet, right? So three slots auctioned. I think the 4th went to BSNL, and 6 operators. So one of the key things that the government needs to do is to open up more spectrum, right? So that we can actually enjoy mobile broadband, and so that operators can actually make a viable business out of it. Okay, so this is a graphic that's talking about how can you do more with the little spectrum you have, or conversely, how can you support greater demand with the existing spectrum that you have. And you know, here are these big circles, and then you see these smaller circles in blue, right? I guess many of y'all can see it, right? So when you look at any cellular network, right, the basic concept is reuse. So you use spectrum in a certain area, but then if there's another area that's far enough, you can reuse that spectrum, right? Because those signals don't travel to the other cell. So it's a basic idea of any cellular network, that you try and reuse to the extent possible the spectrum again and again as you move from geography to geography. Now, of course, the smaller the cell, the more the reuse, right? If you have, let's say, in a given piece of area, you had, let's say, 10 base stations that were equally distributed. If I made it 100, right, I can obviously have more reuse. The challenge, though, is that, and I'm going to be very glib because not all of you all are from electronics and computer science, so I'll be a little bit more vague, or at least you know, sort of make it simple for you. What happens is that more base stations are more expensive for an operator, but also there are constraints to do with where do you locate these base stations, you know, outside. For various reasons, you know, you can't simply put a base station where you want, right? You need permissions and so on. So one of the areas of innovation, in fact, that we're working on globally and in India is this notion that you can, in fact, have sort of, think of it like multiple layers of networks. One is a macro network, right, that covers a large geography. And then you have these small cells, we actually call them small cells, that you may have in a home, you know, maybe in a building, in a small campus, any small premises, that you can also throw in, and through interesting technologies of interference management, because these networks, these cells might interfere, the signals might interfere, you can actually come up with a network that has a lot more capacity, right? So this notion of self-organizing networks with macro cells and small cells is an idea whose time has come in developed markets because the demand for data has really shot up, in markets like India because we don't have enough spectrum, right? So this is an area of intense research, and we actually have products now in the space. Here's an example of a small product that we have. These are actually, these small cells are no bigger than a smartphone or maybe a pack of cards, right? So they are low cost, they're small in size and easy to deploy, and they self-organize, right? So the idea is in areas where you're spectrum constrained, you can throw these in, right, connect them to the macro network, and automatically, right, they can provide additional capacity, provided your interference management technique, you know, is, you know, works properly. And these can be applied not just for 3G, but 4G and Wi-Fi as well. Now, beyond this notion of how do you increase capacity is also the question of how do you deal with multiple technologies, right? So the one that you're familiar with, actually, this stands for GSM Edge RAN, Radio Access Network. So this is, think of this as GSM, right? This is GSM, this is CDMA, this is EVDO, this is UMTS, is, think of it like what you consider 3G. TDS CDMA is something that's deployed in China. LTE, you may have heard of LTE, long-term evolution, often called 4G. And there are two flavors, TDD, time division duplex, and FDD, frequency division duplex, right? So there are all of these technologies. So on the one hand, you have all the different chunks of spectrum, right, in different bands. On the other hand, you have different technologies. And when you design a cell phone, right, it needs to work either with one single technology. So sometimes you have a phone that will only do GSM, or only do CDMA, or only do 3G plus GSM, right? And sometimes you have phones that can do more than one, or more than two, or more than three, or more than four. So what's happening right now is that the globally, because of the fact that we have multiple technologies and multiple spectrum bands, the complexity of actually designing a smartphone in the future that can run on multiple technologies and run on multiple bands is fairly complex. Now, these little arrows from one to the other talk about handover techniques. So let me explain what handovers are. Essentially what happens is, if you have a 3G phone, when you step outside a zone that does not have 3G, typically you'll notice the phone goes to 2G mode, right? I guess many of you all have experienced that yourselves, right? So the idea is that in areas that you do not have a particular technology, you may have a lower technology. If you don't have 3G, it goes to 2G, and you can make your voice call or make your data connection using that technology. So there is a handover that has happened from 3G to 2G. And when you step into a 3G zone, it automatically moves you back from 2G to 3G, right? You've seen that with your cell phones. Well, the same thing now applies when you have 4G, right? So you have 4G and 3G and 2G. Think of it like a wedding cake, right? So it could jump, and there are different handover scenarios. Furthermore, these different networks of GSM, of 2G, 3G, and 4G can actually be in different bands. So if you think of what a smartphone is doing just with the communication side, not even worrying about what it's doing on the computing side, the communication side alone can be very, very complex, right? The reason I'm saying this is to build an appreciation that when you look at your smartphone, there's a lot of stuff happening behind the scenes just so that it can communicate sensibly with the network, right? And in a situation where it can't, it chooses the next best network to connect with. So there is a lot of complexity happening, and now with the advent of LTE-TDD in India in 2300, Airtel and RIL, Infotel, these are two companies that are spearheading their focus on LTE. We're going to see a lot more complexity, and this has to do with, this goes back to how you design your chips and how you design your smartphones. These are the different RF bands. And these are different frequency bands. Each number actually has a code. Band 1, band 2, band 3, they actually map to different frequencies. I won't necessarily go through all of them. And in fact, the handover also can be done using packet switch technology, circuit switch technology. There's quite some complexity here. Now, I want to talk a little bit about Qualcomm for a moment. Because a lot of what you saw on the previous slide is something that we actually do for a living. And really the history of wireless and the history of Qualcomm are fairly intertwined. When I first thought of drawing this chart, I thought I'd do one for the entire industry. And I actually had one for Qualcomm as well, and I compared the two timelines, and they look awfully similar. Apart from one omission, this timeline that's been put together by Qualcomm is not very different from the timeline for the industry as well in terms of wireless communications. So Qualcomm is a company that was founded 25 years ago by professors from MIT. And back in 1988, which also incidentally is the year I graduated, they actually launched their first product, which was a mechanism for fleet companies that own trucks, that would ply across the highways in the US, for them to be tracked by their owners. And they used a mechanism that used satellites. And in fact, CDMA, Code Division Multiple Access, you may have heard of the term CDMA, was actually a technology that was invented really to track trucks. And essentially what CDMA does is it's an efficient way for you to communicate across, using a chunk of spectrum. So that was actually the first product in 1988. Now, of course, it didn't take long for them to realize that, the real interesting case for CDMA was for cellular networks, because it was clear that, there'll be a lot more cellular networks in the coming years. There'll be more and more people trying to make phone calls. So we should use these efficient technologies really for cellular. So the first CDMA voice call, 89. 91 is actually when we had the first GSM network launch, which I haven't shown. 93 is the first CDMA data connection. The first networks, commercial networks launched here. And here is when we actually started a chip division. Qualcomm as a company before that simply built technologies. It actually did not sell any products per se. It would build the technologies and license it to companies to utilize those technologies. right? Which was a very interesting business model actually. In any case, 1995 we started our chip division. We're right now, this division is the number one, because of the division, we're number one company, a fabulous semiconductor company, the number one wireless company. Our market cap today is something like 115 billion, which has actually now crossed Intel's as well. So the company has done very well, and while the initial beginnings were on building CDMA technologies that we would license, we also started a chip division, which has actually grown since then. So that's 1995. 2001, we had WCDMA. So essentially what happened was the GSM networks that initially began in Europe were also looking to move to a technology that would use that spectrum more efficiently. And they saw CDMA as a way to do it. So they actually really picked CDMA and recast it. They call it WCDMA, W standing for wideband, WCDMA. And this really is what is currently used in the 3G networks of Vodafone and Airtel and Idea and so on. So CDMA found another life through the GSM operators. So CDMA and WCDMA, we had EVDO, which was a successor of CDMA. And as you know, EVDO, some of you all may be using these dongles from Tata and Reliance, those use EVDO. And then in 2007 and 2008 is when we had the smartphones enter. Right, 2007 we had the first iPhone, 2008 we had the first clutch of Android phones. And then in 2009 we had the first integrated 3G and 4G modem that was designed by us. 2010 is when we integrated GPS with GLONASS, which I talked about, and 2012 is the first time, which is actually last year, we actually had an integrated chip for smartphones that had the CPU and all kinds of modems rolled in, LTE, all flavors of 3G as well as 2G. So this has been actually the 25 years for Qualcomm from 1988 to 2013, which actually has seen us move from the old days of analog communications all the way through digital communications to a point now we are close to, getting to rolling out LTE networks in India. So, though we're not going to go through all of these today, in each of these different spaces, so video codecs, wireless charging, wireless LAN, RF and antenna, sensors, the OS and the user interface, near-field communications, includes Bluetooth and so on, position location, like GPS and GLONASS, camera, there's a lot of work going on in camera and both single and multiple cameras, displays, wide area networks like 2G, 3G, and 4G, security, right? Apps processor, which is also often called the CPU, the graphics processor, the semiconductor itself, and audio processing. There's a lot of work that we're doing within Qualcomm across our R&D locations in each of these domains. And there's work going on. Most of the work finds itself either through technologies that we then license to others, or in some cases, in many cases, many of those technologies also finds its way into our own chipsets. So we're building a variety of technologies that are finding its way now, not just into smartphones, but tablets as well. In the interest of time, I'm not going to go through that in detail. Now, closer to home, I think what's relevant is that in India, we're actually now building up a fairly strong R&D organization. And in fact, a couple of members of your faculty used to be ex-Qualcomm employees. At least, I'd say, a couple of dozen graduates from IIT Madras are employees at Qualcomm, both in the US as well as in India. There's in fact quite a lot of interactions between IIT Madras and Qualcomm at this point. So these are the offices we have. San Diego is where we're headquartered. Santa Clara, Bridgewater, Nuremberg, Vienna, Hyderabad, Bangalore, Beijing, China, Seoul, and of course, right now we are in Chennai. So we have a strong base in India. Actually, this is the country where we have the second largest presence of R&D. A lot of the engineering development gets done out of Bangalore and Hyderabad. In fact, I believe we are part of the placement as well. I think we made a few offers as well this year. We're also looking at pure research from the Bangalore office. So those of you all who are interested, I'm looking to graduate either with your bachelor's or master's, this could be an interesting opportunity for you. Overall, moving away from Qualcomm for a minute, I also want to say that I think the space of smartphones as such, of course, affects our personal lives, but it's also one of the hottest fields for innovation today. And I'm saying that not just because I belong to Qualcomm, but because we're beginning to see interesting ways in which smartphones are being used or tablets are being used. So we are seeing fields like education, like healthcare, in some cases governance as well, utilize these platforms in very, very interesting ways abroad and now in India. So there are pilots, there are trials, there are small projects, in some cases commercial services that have been deployed by using smartphones in adjacent industries that are leveraging the power of this in interesting ways. So I think that's an important development. In fact, to give you a bit of a feel for what's coming beyond what you may have already experienced, we have a little demo zone here. And Varun, who's actually seated right here, actually will, can show you some of these demonstrations. So I just want to give you an idea of these demos. You can check it out after the talk, after our Q&A. So this one, Vuforia, actually uses something called augmented reality. Have you all heard about augmented reality? Okay, this one is not drawing a lot of nods, so let me explain. So essentially the idea is that you point your camera of your smartphone. Just imagine you have a smartphone with a camera, right? The camera shutters open. You point it at something, right? You're seeing something come up on the screen of the smartphone. What augmented reality does is that it processes what the camera is seeing, recognizes this, objects in the scene, and then layers virtual objects on top of the image. Okay? And it does that 30 times a second, all of this. So that from your perspective, it really looks as if you've got a natural scene with something artificial put on top of it, right? So why is this important, or why is this interesting? So we're going to see, Varun is going to show you some demonstrations at the end of this lecture. But you can, I'll motivate the idea through some examples. You could imagine that, let's say, you have a textbook, right, which is showing, let's say, a water molecule. Now, a water molecule, as you know, has a three-dimensional shape, but you can't see it on the textbook. You point the camera of your smartphone to that picture, and you can see it in 3D, and you can, with your finger, you can move the molecule around, right? So you can do that. You can use that in all kinds of interesting educational applications you can imagine, especially where three-dimensional information is of interest. People are using it for products. Let's say you're launching, I don't know, a washing machine in a rural area. It's difficult for you to provide instructions in a written form. You can actually do the same thing. Point your camera at the knobs of the washing machine or whatever device it is, and it'll suddenly pop up different pieces of it'll light up different parts of the knob and say, well, this one, if you touch it in your favorite language, it can actually tell you what it does, and so on. So essentially making a world more intelligent, the real world more intelligent, right? Real estate agents have used this in Europe. You point it at an apartment complex, it'll immediately tell you which of the apartments are vacant, and there's a price tag associated with each of these. So there are all kinds of interesting things you can use it for, at this time, but we believe it's still scratching the surface. So Vuforia, which is really our sort of code name for augmented reality, is now just sort of scratching the surface for what we think smartphones can do. This is one space. The other is audio, SRS, surround sound. Now, I think the demo here just shows surround sound. We have another technology which I don't think we're demoing, but actually it's on Varun's phone. It's called Fluence. That technology essentially has two microphones. You've got a smartphone with two microphones, one in front, one at the back. And essentially what happens is the microphone at the back picks up the ambient noise. So that what happens is it cancels the ambient noise when you're talking in the phone, and all that the other person on the other end hears is a clear voice. Because especially useful in Indian conditions, where, which can be quite noisy. So I think we've got some audio application, video again, other interesting things, and gaming as well. which actually shows the power of modern GPUs.
And whatnot. What you can also actually do is you can change the transparency of the screen. So you have like the full body, and you can see it. And all of this is being rendered live in real time. So what it's doing right now is actually recognizing the pattern on the target. And you can think of this target as maybe I know probably you guys don't have it here, but maybe you have a biotech department, and this is like this could be a whole wall in the biotech department, and you could just point your phone to it. And they've done it on a human body. You could do it on a cell. You could do it on anything that you're researching on, just to make it easier for other people to understand what it is you're talking about. So what this proton does is, it actually renders the car on top. And again, this could be anything. This could be a newspaper ad. This could be a billboard. This could be a hoarding. This could be a thing on your TV or whatever. And again, you can kind of move it around, all around, and you can go close and you can see the car from different angles.
So let me stop here and actually take some questions. It's been a long monologue. I think, but the talk that the talk here was focused more around smartphones and technology. But feel free to ask me questions outside of what I've shown in the talk as well. I think we've got a few minutes. First. Any questions for anyone? Yeah. Yeah. So the question is, at what point will we see 2G completely phased out of India? And you made the point that you don't see 1G anywhere. Well, you don't see 1G because we really didn't have 1G networks in India. By the time we had our first set of mobile wireless communication services, the world had already moved to digital, which was 2G. Now, in a country like the US, most of the operators there, they're actually phasing out 2G by 2017. And most of the sales of new devices are actually 3G devices, something like 70 to 80%. But there's always a segment of the population that will still be on 2G. In the case of India, I believe it'll take even longer. And that has to do with the fact that 2G feature phones will always be less expensive than 3G smartphones. Now, the prices, of course, are coming down, and we'll see a greater preponderance of 3G smartphones in India. But we will always see 2G because, like I just mentioned earlier, there's a significant chunk of the population in India that is very, very poor. And I don't see them moving to 3G smartphones tomorrow. So 2G will probably cross into the next decade for sure. But clearly 3G and 4G will begin to dominate. We're already at the point where we are not seeing an increase in 2G subscriptions. But so if you look at 2G and 3G, if you drew a plot of the total number of subscriptions for 2G and 3G, 2G is flattened out in India. It still continues, but the increments have flattened out, whereas for 3G it's now on a ramp up. But it'll take a while for 2G to go away. It's going to take, it'll still be around for a long time. Yeah.
Every field of challenges that a company faces coming up with a smartphone, is it as in the competition or of a smartphone?
Okay, so short answer to your question is the fact that if we were to build smartphones, we would land up competing with our customers, right? So that's like not something that would go well with our customers, right? Because on one hand, you're selling them something. On the other hand, you're building something to compete with them. So that's basically, you can make that decision, but if you make that decision, you should be well aware of the fact that most of your customers will go away. Now, if you believe you can build a smartphone and be as successful as some of the other companies like maybe Apple and so on, and you have the core competence to do it, and it's worth the risk, you would. But I guess the management at Qualcomm doesn't believe that that's the right path. That said, there was a time when we actually tried to build a couple of phones, because CDMA was taking time to gain traction for a very brief period, but we sold off that business. But the broad answer is we're not doing it, and it's unlikely we will do it in the foreseeable future. Please.
Can you explain the dip in the graph?
Oh, the dip in the graph, yeah. So that's actually, I don't need to see it. I think you guys remember, right? It's a red curve that actually had a little bit of dip. Okay, so the way in which telecom licenses were given in India in the initial years was the following. And this is partly reflective of the fact that we were far more socialist in our leanings, in the early 90s than we are today. The way that licenses were given were the following. So, for example, if you wanted to start a service, you would get a license, okay? And the spectrum was really given to you pretty much for free. Okay, so you got the license to operate, and they would start you off with some spectrum and say, okay, all right, run with this, try to build your network with this spectrum. Now, if you have more subscribers, right, beyond a certain amount, then you'll get more spectrum. You got the idea. And that was, again, for the most part, free. So the idea was, the policy was called subscriber-linked criteria for allocation of spectrum. So what that meant is the more subscribers you had, the more spectrum you were given, right? And spectrum, typically, the lifetime for spectrum was as long as a license, which could be 20 years. And more spectrum is always good. Like I mentioned earlier, it's like oxygen. So operators wanted it. So what happened was, for a very long time, not only were operators following this mantra that just let's go get subscribers, regardless of whether they're profitable or not, because we'll get more spectrum, but also the valuation of these companies, of the mobile operators, were based on the number of subscribers they had, right? So there was this kind of, the ramp up. Part of the reason for the quick ramp up was everybody was running to get subscribers, profitable or not. What happened afterward was when the auctions regime began, right? And you've read, I'm sure you've read this in the papers. Once the auction stepped in, and government correctly realized that the scarce resource is not licenses, right? You can keep giving out licenses, like, getting a driver's license, right? That's not a problem. The issue is, the constraint really that we have, the precious national resource that is limited, is spectrum. So what we should be pricing is what is limited, right? So they said, no, we should be auctioning the spectrum, which is what is done in much of the world, which was and is done in increasingly more number of countries. So they said, no, what we're going to do is, it doesn't matter how many subscribers you have to go for an auction if you want more spectrum. Now suddenly it didn't make a difference how many subscribers you had, right? Because the spectrum you were given was completely delinked from the number of subscribers you had. So then operators said, what's the point of me holding on to these subscribers that are not making a lot of money for me? So the thinking in the operators changed, because the spectrum allocation did not follow a subscriber linked criterion. To add to that, the expenses went up. So labor, a lot of the fixed assets like towers, rentals for it, rights of way, a lot of these things also went up in price. So a lot of the dip is to do with subscribers that operators said, we really don't care for these subscribers. We're not going to give them, compelling tariff packages. The tariffs must reflect the cost that we incur in serving them. So what happened was those subscribers actually fell. So that was one. The second effect also, which is also contributing to this, is the fact that back in 2008, 2009, during the Raja era, he had given out licenses to all kinds of companies, questionable companies with questionable backgrounds as well. And these companies were in the business simply to make a quick buck, build up subscribers and sell the company. So they had actually really, really low prices. Because of that, subscribers said, we'd like a smartphone with 2 SIM cards, right? One will be the old operator I have, the second will be this cheap operator for outbound calls, right? With this new operator, maybe fly by night or whatever, but it's a cheap way for me to make phone calls. So when you had this phenomenon, we had this additional effect that a single person had 2 subscriptions. Now, once these companies either collapsed or folded, as we've seen, some of them, of course, went behind bars, as you know, the need for that second SIM card went down, so that the second subscriptions that people had also fell off. So because of a combination of these 2 factors, we're seeing a bit of that dip. But it's not like the story's over. It'll probably continue. It's not going to go down, obviously. It's probably an artifact, but it'll probably continue, but it's not going to grow much more for the reasons I explained, which have to do with economics and the fact that we have a large segment of India that is very, very poor. But clearly, I think the big picture on that slide that you should remember and take away is the fact that data is just beginning. It's 10 years separated from where voice was, and that's on a ramp up, thanks to 3G smartphones and 4G smartphones in the near future.
Sir, I have a question. So, there are a lot of articles and talks about the adverse effects of the smartphones in brain. So brain. So what is the state of research or the latest thing research which is being done on this aspect?
So when you say adverse effect on the brain, are you talking about the fact that people are getting duller because they don't have to do things the smartphones do it for them? That kind of stuff? Or?
No. So adverse effect, like it is being told that some type of negative effects on the brain based on the electromagnetic waves. And all
Oh, I
those
see.
things.
Okay,
Yeah.
radiation. All right. Right. So because there's actually a theory which what I just mentioned. Also, there's some interesting work that says essentially the logic being that ever since we had calculators, we can't do our tables properly. So by extension, but I think the point you raised about radiation is a good one. I think the question of electromagnetic radiation has come up in two contexts. One has been on smartphones, because you put them against your ear, often pretty close to the to where your brain is. The second is, of course, also towers that also radiate electromagnetic spectrum, right? There have been a lot of tests that have been conducted, and in fact, the Indian courts have also ruled in many cases against placing towers, the cellular towers, in localities, in residential localities. In fact, some of them have been, you may have read this in the papers as well, they've been asked to dismantle them and move them to locations where they may be less harmful. But largely, I would say the data on this, I think the jury is still out on a lot of this stuff. But what is clear is, and what I think we need in India, and I think the Indian government has woken up to the fact, is that a lot of the inexpensive phones that initially used to come in from China were not that stringent in terms of ensuring that the electromagnetic radiation, enters your brain or your skull cavity, is limited. So there's something called SAR, the SAR rating, which talks about how much electromagnetic radiation, on average, is subjected to the person using the mobile phone. So these SAR ratings now are being tested. In the US, they have something called the, FCC, that actually checks the SAR ratings for devices. So there's a lot more testing going on to ensure that at least we don't have abnormally high exposure to radiation. Because some of the cheaper phones, some of them don't even have a brand, that are being pushed into rural areas, could have a health effect. But for most of the smartphones and cell phones that coming in from recognized brands, they have a fairly strict SAR rating. And based on their understanding, it doesn't cross the limits where it could be harmful to health. But that said, I think the jury is still out. For the most part, we believe it's safe, provided it's within the appropriate SAR limits that have been. I mean, we have research that's been done in the US, but I guess in the Indian context, there's not been as much. Sorry.
You said that Qualcomm started with M2M communications. So my question is actually on M2M. Do you see the communication technologies or the data transfer being on the more different than the communication channels being used to access internet, especially in M2M industry?
Yeah. So short answer is yes, they are different. They are different for a couple of different reasons, because when you say machine to machine, M2M stands for machine to machine, there are different kinds of interactions. For example, you can imagine that you have a sensor that automatically reports the temperature of a particular weather station to a nearby location using wireless. Well, that has to wake up once a day or once an hour, right? So you can actually design devices and design them in such a way that they only wake up every so often. So the way you would design the devices and the way the protocols you would use to communicate can be done in such a way so as to minimize the use of resources, wireless resources. So that's one. Second is that there are also some M2M applications that we're seeing in the home that are also changing the way we design networks. So there is this notion called a connected home. We didn't have time to cover it. But essentially the idea is that we're going to, and this is already happening in many developed markets, especially in Korea and Japan, not so much in the US yet, where you enter the home and pretty much everything is, got some smarts in it, right? Some chip or the other. They all connect, they can all be controlled, through your smartphone. There's a very interesting technology we have called Skifta, where essentially you have a smartphone, you have a TV, you've got some interesting content, and literally you do a gesture like this, from this to the television, and the content appears on the television. So there's connection between devices. So there are interesting new ways for devices to communicate. There's also stuff you're putting inside cars. So there's a rich set of applications. There's a lot of stuff happening on in the health space as well, where there are issues to do with, back to what you said, how do you do it in such a way that the radiation exposure is minimized, things embedded inside, in fact, even cardiac monitors and so on. So there's a lot of stuff going on in that space. So broadly speaking, yes, M2M is different. The big thrust today is on smartphones, but once we touch that 5-6 billion number, the new connections will mostly be M2M. Yeah.
Do you see the communication channels being different from the technologies that use internet, for example, GPRS or 3G?
No, I think what's going to happen is that the way in which the newer releases of the same standards will actually have options for these kinds of communications. I'm not sure that will be completely new. We'll move from 3G to 4G something else. It will be within that standard. It's just that the kind of protocol you would use or the variant that you would use would be optimized for M2M. Last question. Oh, okay. Last two. Yeah, so firstly, I don't think 2G will be phased out in 4 or 5 years. I think it'll take longer. Second is, I think it depends on the application. So for example, if all you're doing is sending a temperature reading, that can be done in 100 characters, right? So an SMS is enough. On the other hand, if what you want to do is to do a video conference with a remote specialist sitting in a metro and the patients in a rural area, then obviously, if it's a video conference, you'll need 3G or 4G, typically. So I think it depends on the application. My sense is that depending on the kind of service you're offering, if you're simply sending, key body parameters, you can use a low bandwidth technology like SMS or 2G GPRS Edge. But if you need more bandwidth, 3G and 4G is definitely the way to go. And in our understanding of the situation, given the limitation that we have today in terms of the number of doctors available in rural areas and the lack of interest of doctors to move to rural areas, this kind of a remoting of healthcare, as we've seen in education as well, is expected to happen in India as well. So that would probably be on 3G and 4G. Last question, sorry.
How do you pick the next technology to work on? You can't be reacting to market trends. You have to vision it. Do you have a process for that?
Yeah. So, when I joined Qualcomm 5 years ago, I read a book called The Qualcomm Equation. It's actually available in bookstores. And it talks about the philosophy of the founder, Irvin Jacobs. And he was one of the guys who, would always use some of the earnings, a good chunk of the earnings, to explore new ideas. Very innovative by spirit. I'm giving a long answer for a reason. When we evaluate employees today at Qualcomm, and I bring this up because when I saw it for the first time, I was myself surprised. There are 3 dimensions: innovation, partnership, and excellence. And we evaluate this for all employees, right from whether the person is, even let's say a secretary to the CEO. And I've always wondered, why would you apply this to somebody having a support role? But the belief of the founder, and that's actually percolated through the organization, is that there is innovation. There can be innovation in almost everything you do. So right now, what we do is that we actually have different. Well, firstly, we have a fairly large research organization that's pushing the edges on various technologies. We also make investments. So we have one going on artificial intelligence called NEO. There's stuff on new display technologies that are actually not in the core competence, not in the core areas that we've been working on traditionally. So Typically, we also invest in these areas either ourselves through employees or in some cases through acquisitions. We also have a very strong ventures arm. We have one in India. We've invested in about half a dozen companies in India where we see something interesting. And the intent of investment is not so much to make a profit on it. It's more to stimulate and grow the ecosystem, the mobile ecosystem, and ensure that we are part of it. So I think the process of innovation is fairly widespread. We also have a sort of a program within the company so that it's called Quinn. So for example, if I as an engineer or as an employee have an interesting idea, I submit it to a panel. And if the panel believes that this one has merit, right, it doesn't need to be fully proved out, but at least has some merit, you can actually devote some part of your time for furthering that particular project with like 3 or 4 guys together. And if that works out well, you can build a business around it. So there are different mechanisms that are used, but innovation is certainly one of the key elements of Qualcomm, at least in my opinion. And it's innovation not just in technology, it's also in business models. One of the first learnings that we had was, like I showed you, when we first came up with the idea of CDMA, the world was at that time GSM. And, in telecom, it's strange. You need to change, if you have to change things, you have to change things on the network and the device side, right? Because the two have to talk to each other. So it's a bit of a chicken and egg when you have a new technology. And so the decision was made, and this was a business model innovation, that look, we don't actually have to fight with people who want to do GSM because we have CDMA. What we can do is we can license the technologies to those who want to do GSM so they can do WCDMA, which is what they call 3G now. So I think innovation, not just on the technology side, but also on business model, is something that we've been pursuing. But I think there's a limit. I mean, it's impossible to predict the future. All you can do is you can try to be as prepared as you can and allow imagination, create a space for engineers to let their imaginations run free to an extent. Right? Obviously, you've got to make sure that you ultimately have to pay everybody salaries. But I think we do. I think Qualcomm does a fairly good job, at least in my opinion.
What is beyond smartphones?
Beyond smartphones, well, I think M2M was one that we talked about, but there are also new interfaces. Like, for example, there are ideas of leveraging the same capabilities inside glasses, on watches. We have this concept of sixth sense, which I have not talked about here. But the basic idea is that, at least based on our current understanding, we don't see the trends of smartphones and tablets ending anytime soon. We think that has a very long life ahead of it. But who knows what's going to come next? So we are, like I just mentioned, we are looking at different other device types and other mechanisms to deliver those kinds of functions and services through other form factors. But it's not a single answer, right? It's also not clear how people will use these devices, right? For some people, instead of having a smartphone and a tablet, they prefer a 5-inch smartphone, right? Some other people don't like any of these. They want a laptop because they want to do their Word and Excel and PowerPoint, and they like the keyboard. So I think it's probably going to be diverse. I don't think there's a sort of right now, of course, smartphone is a dominant device type, but in the coming years we could see some changes on that front as well.
Okay,
All right.
Let's thank Dr. Sibal.